find the thickness of a thin wire. Here the wire in the sense it may be any material made up of very thin. Either we can use wire or sellotape. Okay. This is the main aim of our experiment. And coming to the formula, we are calculating the thickness. So it is mentioned as T, which is equal to L lambda divided by 2 beta. Okay. Now we can see what is meant by air wedge. I think here you can see a glass plate. We are using two glass plates. One end is stretched by rubber band. That is, here it is tightly stretched with rubber band, and here we can see some gap. Consider this as first glass plate, and this one as second glass plate. Here one of the end is stretched with rubber band, and in other end we will be having slight gap. So in this gap we will be getting a wedge shape in which air is filled here, and if a light falls on this glass plate, interference pattern is formed. I think you have learned about Newton's ring. In Newton's ring you will be using a circular lenses, so you will be getting circular fringes with one dark and bright spots. Similarly, instead of circular lens, here you are using a glass plate which is flat. So your interference pattern will be a straight line. So you will be getting like this of fringes with one dark and one bright lines. So this is the basic principle behind this air wedge method. Now we can see what are the apparatus required for this experiment. First is the source. Here we are using the sodium vapor lamp, and second one is the travelling microscope. I think you have been seen this same apparatus in Young's modulus. In Young's modulus you will be using this vertical scales. Either for this air wedge method you will be using this scales, that is a horizontal scale, and you will be having one glass plate and an inclined glass. So these are all the apparatus required for doing this air wedge experiment. Simple experiment. We are having only two tabular column. For the first one, that is the table 1, we have to determine the fringe with beta using this travelling microscope. So the least count of this microscope is 0.001 into 10 power minus 2 meter. Whereas in screw cage it is 0.01 into 10 power minus 3 meter. Here for this travelling microscope the least count is 0.001 into 10 power minus 2 meter. So here we have given the order of fringes n, n plus 5, n plus 10. It goes up to n plus 50. You have to find the main scale reading, MSR, vernier scale coincidence, total reading, width of 5 fringes, mean width. This is your first tabulation. And second one is determination of distance between edge of contact and fiber.